Hi y'all, this is an introduction to categorical syllogisms, and in this we will be discussing the sort of four types of categorical claims that are used to create categorical syllogisms, which are just arguments with two premises and a conclusion, and then we will discuss the Venn diagram method for determining validity and invalidity of these syllogisms. So up until now, we've been talking about what we call propositional logic or sentential logic. And categorical logic, what we're going to be discussing here is a little bit different. So propositional logic is concerned with the logical structure of sentences that are put together via these logical operators. So conjunction, conditional, disjunction, negation, they're all sort of created by modification of sort of existing sentences. So you take a sentence like today is Monday, and you take a sentence like it's sunny outside, and you can construct a new sentence by conjoining those with a logical operation. So you could say today is Monday and it's sunny outside. So you've made a conjunction. Categorical logic, though, is concerned with sort of the interior structure of categorical of claims, and in this case we're talking about sort of the structure of categorical claims. So these are claims about categories of things. So for instance, all cats are mammals is a categorical claim, and under propositional logic, right, the previous logic that we talked about, there's really sort of no way to sort of capture the interesting logical structure of this sentence. So under propositional logic, this would just get sort of just translated as P or Q or whatever, right? It's just a atomic sentence. So we're going to be looking at sort of the underlying structure of this sentence a little bit more closely. So with categorical logic, this sentence will sort of translate as all SRP. So this is one category cats and another category sort of mammals, and what we are saying of cats, maybe the set of cats, you could think of it that way, is that the set of cats is contained in the set of mammals. So as we sort of move forward, we're going to be looking at different types of categorical claims that all make assertions about sort of set membership between sort of different categories. Okay, so what we are dealing with are, in this case, are just sort of four types of categorical claims. That there are an infinite number, but we're just going to sort of deal with four. And in particular, we're dealing with claims that just make assertions about the relationship between sort of two categories of things. So in one case, we'll have sort of the subject category, and then we'll also have sort of a predicate category. And the assertions will be about sort of membership between those membership relationships between those two categories. So for example, all cats are mammals is an example of a categorical claim that is talking about the set of mammals and the set of cats, and is saying that cats are members of that set. So we have two axes of things that will generate these sort of four types. So one sort of type of categorical claim is the universal. So the universal categorical claim will be talking about the entire set of the subject category. So an example of a universal claim is all cats are mammals, right? Is that it's talking about all the cats, whereas there's this sort of other type called the sort of the particular, which is talking about sort of some of the cats. So there's the difference between talking about everything that is an S in the subject category and just some of the things that are in the subject category. So that's one axis. The other axis is the difference between affirmation and negation, or affirmative and negative. So with an affirmative, are saying that members of the S are also members of the predicate or P category, and then with the negatives, you're saying that members of the S are not members of the P category. So you take those two axes together and you get these sort of four types. So you get two types of universals, an affirmative and a negative, and then you'll get two types of particulars. So we'll just sort of briefly go through these four before we move on. So starting with the universals, we have a universal affirmative and a universal negative. So remember, what makes them universals is that you're talking about everything in the subject category, everything that is an S, and the sentence "all cats are mammals" is an example of an universal affirmative. So all cats are mammals is saying that everything that is a cat, that's the universal part, is a member of the mammals category. So everything that is a cat is also a mammal. So that is universal to all cats. And also universal to all cats is we can say something negative, right? We'd say that of all cats, there are some things that all cats are not. So for example, all cats are not reptiles, or more succinctly, no cats are reptiles. So a universal negative is again talking about all the things in the S category, but is saying that none of them are members of the predicate category. So no cats are mammals would be an example of a universal negative. So real briefly here before we're sort of moving to the particulars, we have sort of shorthand for these types. The universal affirmatives are sometimes referred to as A claims. Universal negatives are sometimes referred to as E claims. And then with the particulars, the particular affirmative is the I, and the particular negative is the O. So sometimes, just to help, we will refer to these in this kind of shorthand way. Okay, so universals, what makes them universals is we're talking about everything in the subject category. In the case of particulars, we are talking not about everything, but just sort of some of the things. And in categorical logic, some just translates to at least one. So we don't know anything in terms of numbers other than that there's at least one thing that is in the subject category that either is, in the case of the affirmative, or is not, in the case of the negative, a member of the predicate category. So for example, using cats again, we can say, well, look, there's at least one cat out there, and I don't know precisely what the percentage is, but for our purposes, we know that there's at least one cat that is black. So we would say some cats are black, some S are P. And of course, we also know that there are some cats out there that aren't black, and there's at least one. We don't know precisely the percentage, but we don't need to know that for these purposes. So we know that there's at least one cat that isn't black. So there we have it. Our four types of categorical claims are universals, the A and the E, all SRP and no SRP, and our particulars, the I and the O, some S are P and some S are not P. Okay, now that we have our four categorical claims figured out, the next thing we want to talk about is how to represent these claims visually. And the way that we're going to do that is through Venn diagrams. So eventually, with these Venn diagrams, we're going to develop this method for determining validity of these categorical syllogisms. Those are the arguments that will be sort of made up of these categorical claims. But first we're going to talk about these the visual representation of Venn diagrams, and we'll just sort of start with a two-circle Venn diagram. So a two-circle Venn diagram, what this kind of represents is that each circle represents a category, and being inside the circle indicates the membership in that sort of category, and then being sort of outside the circle represents non-membership. And you'll see here that we have two circles that sort of overlap, and in that overlap would be being members of both of the categories. So what I have here is the circle on the right is going, excuse me, left is going to represent all red things. The circle on the right is going to represent sort of birds. And we're just going to talk a little bit about the different sort of areas here. So, for instance, again, sort of being in the left circle means that you're sort of a red thing. Being in the right circle means that you're sort of a bird, and of course you could be sort of in this sort of overlap area, this area that kind of looks like a football, and that represents sort of being both. So you're both sort of a red thing and a bird. So in the middle here would be just sort of anything that's sort of a red bird. So see, red birds are cardinals, scarlet tanagers, and then just sort of anything else that is a red bird. So summer tanager and so on and so forth. So that's sort of in the middle, so you're both a sort of a red thing and a bird. And if you're outside of the overlap, well, then you're a member of one, but not a member of the other. So here would be sort of a red thing on the left here that isn't a bird, so like a stop sign. And over here, then you'd be a bird, but just a bird that isn't red. So any non-red bird here would work, but we'll just sort of put a robin. So robins are gray and orange, and they don't have any red in them. So that's kind of how to understand sort of a two-circle Venn diagram, and I guess I should sort of mention that if you're outside of both of these circles, then you're neither a red thing nor a bird. But we're not going to sort of deal with that. We're going to work primarily sort of in inside the circles. So to continue here, in order to do the Venn diagram method, we are going to end up using sort of these three-circle Venn diagrams. And I just want to talk a little bit about that before sort of moving forward. Three-circle Venn diagrams is situations where you have sort of three categories of things instead of just two. So here we have bottom left of red things again, bottom right we have birds, and then let's add a third category. In this case, we'll be talking about sort of migratory animals. And so I just want to briefly kind of go through these areas, because once you add sort of a third category, you double the number of areas. So you'll see sort of there's a lot of overlapping going on, and so you have situations where, and I just want to kind of talk through some of these. You have situations where the overlap is maybe kind of confusing, or sort of what's going on where. But it's the same sort of general idea, is if you're in the circle, you're sort of a member of the thing. If you're outside of the circle, then sort of you're outside of the thing. You're not the thing. So here you could see that all three circles sort of overlap in the middle. That would represent being all three. So right in the middle, you would be a red thing that is a migratory animal and that is a bird. And if you want an example of that, that's the scarlet tanager. So the scarlet tanager doesn't stick around; it goes south for the winter. It's a migratory animal. But down here, right below that area, would be a red thing, a bird that isn't a migratory, and that is a cardinal. Cardinals don't migrate. They stick around all year long. So you've got sort of this third category that adds things. And of course you have these other sort of areas too. So here's a red thing over here, bottom left, red thing that isn't a bird, that isn't a migratory animal. So that's, the stop sign again. Birds that don't migrate, that aren't red. Birds that do migrate, that aren't red, would be up here. So migratory bird that isn't red would be pretty much any warbler. So put like a yellow warbler in here. And here's up here at the top, here's maybe a migratory animal that isn't a bird and isn't red. So not a bird, but isn't red, would be like a tuna, or a dolphin. So those are animals that aren't birds and aren't red, and so on and so forth. So we have all these areas that will sort of come into play when we start talking about sort of arguments that are made up of these categorical claims, because these arguments all involve sort of three categories of things instead of just two. Okay, so we wanted to talk about the Venn diagrams for the A, E, I, and O claims, for our four categorical claims. And each of these claims individually will involve only sort of two categories of things. So for instance, the A claim is all SRP. So you have here's a Venn diagram where we can put sort of the S on the left and the P on the right, and so whatever our S and P are, we will sort of represent it like that. But let's do an A claim. Let's do all SRP and talk about kind of how to represent that. And for our purposes, just sort of thinking, we'll make S cats and P mammals. So just to give you some context here. So if this sentence is true, all cats are mammals, then what this means is that that everything that is a cat, so let's look at the cat circle here, that everything is a cat is a mammal. So that everything that is in the S circle is actually inside the P circle. So another way to sort of think about that is that this area over here, and I'll just kind of outline it here, this area over here, if this sentence is true, would be empty. So there would be nothing that is a cat that isn't a mammal, right? All the cats would be sort of living over here in the overlap in the middle. So if this sentence is true, then this area would be empty, and we're going to indicate that or visualize that through shading. So we're going to take this area and just kind of block it out from it having any sort of members that our shading is going to sort of indicate sort of emptiness. And I should sort of mention that different systems that use Venn diagrams, so it's not just logic that uses Venn diagrams, but you also find it in math and other sort of set theory stuff. They shading might mean something else, but just keep in mind that in this case, if you see something sort of shaded in, that means that that area is empty. So just write that down here. So shading sort of means empty. And so all A claims, no matter what it is going to be sort of represented visually in that way, that you're going to have a sort of crescent shaded in. And the other sort of universal, the I claim, the one that says sort of no SRP, is also going to be represented with some shading. So if you have an I claim, like no cats are reptiles, then instead of this area on the left being empty, it will actually be the area in the overlap or the middle that is empty. And so again, that would be indicated sort of through shading. So what we would be saying here is that there's nothing that is both. There's nothing that is both a cat and a reptile. So that area in the middle is empty. So nothing in the middle. Okay, so those are the universals. With particulars, we aren't going to be talking about emptiness, so the picture is going to look a little bit different. So at the bottom here, we'll start with our particular affirmative, which is some SRP, and so this is the I claim, some SRP, and so let's continue with our model here with cats, and we could say, I think we did black things. So with some, recall that what some means is that there's at least one. So what you know for sure when you say some S or P is you know that there's at least one S that is a P. So you know that there's sort of at least one thing. So if you have a black cat, think about that black cat's name, but I had a black cat, her name was Gabby. And so we could say, well, I knew that there's sort of at least one cat that is black, and that was Gabby. And so to indicate that sort of at least one thing, so we're not, like I said, we're not going to do sort of emptiness. We're going to do this sort of one member, this at least one thing that we're going to do, and that's going to be indicated with an X. So to do some S or P, we're going to say, look, there's at least one cat that is black, and that lives in this sort of overlap here. So there's Gabby, or if you have a black cat, that's your black cat's name there, and that's how we sort of indicate the particulars. So the particulars are just involve an X, and in this case, with the I claim, it goes in the overlap. Now with the O claim, right, the sum S or not P, we just have to move the X to a different spot, because what we're saying with O claims is some S are not P. So here we got, cats again, and here we have black things, and what we know, especially if you have a cat that isn't black, we know that some cats are not black. So Both of my cats are not black, Lily and Lulu, but for our thing, we're just going to talk about one of them. So we'll talk about Lily, and we'll say Lily is a cat and isn't black, so she would live over here. So there's Lily. She is a cat that isn't black, and so there's at least one thing that is not black, but that is a cat. So now we have sort of a visual representation of our four categorical claims, and we can go forward and start talking about categorical syllogisms. Okay, so categorical syllogisms. Categorical syllogisms are arguments that are made up of these categorical claims. So here's an argument that is made up of all A claims. So they're all universal affirmatives. We have all cats are mammals, all mammals are reptiles, and therefore all cats are reptiles. So it's kind of a weird sounding argument, but nevertheless, it is an argument that is made up of all four is made up of some combination of the four categorical claims. In this case, they're all A claims. But here's an argument that's a little bit more sort of mixed up a little bit, so it's not all A claims, but A claims and I claims, E claims, universal affirmatives and universal negatives. We have all cats are mammals, no mammals are reptiles, therefore no cats are reptiles. So there's another example here. Here's a third example, all cats are mammals. Some cats are brown, therefore some mammals are brown. So now we have an argument that has a universal, an A claim, has a particular affirmative, an E, and the conclusion is that is also an E. And I should sort of mention here, and I didn't sort of indicate this, but all these arguments are the last sentence is the conclusion. So I should go here and just indicate. There we go. There's a line. Those are the first two are the premises, and then the last one is the conclusion. So just to be clear here, what's going on. And then finally, here's a last argument. Here's a nice combination of things. We've got a universal negative. No cats are reptiles. Then we have a particular affirmative that some cats are brown. And then the conclusion is a particular negative. Some brown things are not reptiles. So you have a real nice sort of combination of things here. So what we're going to be talking about, and the Venn diagrams are going to sort of come into play here, is these categorical syllogisms, these arguments that are made up of these some combination of these four categorical claims, and we're going to use the Venn diagrams, the visualization that we just sort of discussed, to determine whether or not these arguments are valid. And in this case, all of these arguments are actually valid. So not only are these sort of arguments that are made up of these some combination of these categorical claims, but that they are valid. So I want to talk, this will be sort of the last thing that we sort of discuss, or just sort of features of these categorical syllogisms. The categorical syllogisms all have three categorical claims. So that's all syllogisms are like this. There's always sort of two premises and a conclusion. And then furthermore, I don't know if you noticed from the examples before, but you can go back and look. But all of the arguments have exactly sort of three terms, which is to say that they're always about sort of three things. So for example, the cats and the mammals and reptiles argument, you say sort of all cats are mammals, and all mammals are reptiles, therefore all cats are reptiles. That argument has exactly sort of three categories: cats, mammals, and reptiles. Um, and so did the second argument, but it's just a little bit different, right? So all cats are mammals, and no mammals are reptiles, therefore no cats are reptiles. Same kind of deal. The argument has sort of three terms. So again, all the categorical syllogisms are going to be like that. They are all going to deal with sort of three terms. And we're going to refer to them by S, P, and M, and I'll talk a little bit about what that means here in a second, but just to be clear before going forward is that each term is going to appear twice in the argument. So with the cats, reptiles, mammals things, mammals appears twice. It appears in both of the premises. Cats appears twice. It appears in one premise and then the conclusion, and then reptiles also appears twice. It appears also in a premise, just a different one, and then in the conclusion. So again, every categorical syllogism is going to be like this. It's going to have three terms, and each term appears twice. So one of the term, which we refer to as the P term, or excuse me, the major term, which we indicate with a P, is the P because it's the predicate term of the conclusion. So you look at if you want to know what the major term is, you just look at the conclusion, and whatever the predicate is, that's going to be the major term. And so that term is the predicate of the conclusion, and then it'll appear in one of the premises. The minor term, which we call the S, is just the subject of the conclusion. So there's the predicate of the conclusion, the subject of the conclusion, and then this S term will appear in the other premise. So the P term, the major term, will appear in one premise. The minor term will appear in the other. And then in the premises, but not the conclusion, is the middle term. So if you want to figure this out, you just look for the term that isn't in the conclusion, and that is your M. So that's sort of the standard way to sort of indicate or to give letters to the three terms in these categorical syllogisms. So from this, there's actually sort of a finite number of categorical syllogisms. So if we adopt this sort of convention of sort of naming the terms, and we only use categorical syllogisms that have some combination of the three categorical claims, and there's four of those. So 4 times 4 times 4, and there's only sort of three terms. Then you're only going to get sort of so many sort of terms, or excuse me, so many syllogisms. And so there's a finite number, 256, and only 15 of them are valid. And so what we need to talk about next is just kind of what this method is going to look like. So the Venn diagram method for determining validity is a way to look at these 256 sort of different sort of categorical syllogisms, and using this sort of Venn diagram visualization, we can actually talk about whether or not these arguments are valid. And remember that only 15 out of the 256 actually are. So what we have, and we're going to discuss this in a later video that will sort of I'll go through some examples, is a four-step process, and I just want to talk through what that process is, and then in the next video I'll give you some examples. So the first step in the process is to determine the three terms, right? So we got our P, S, and M, and major, minor, and middle. And whatever our argument is, we just want to identify the terms. So the major term is just the predicate of the conclusion, and it is going to be in the one of the premises. The minor term is the subject of the conclusion, so the P for predicate, S for subject. And then the middle term is whatever is not in the conclusion but is in both of the premises. So we're just going to identify our terms and then rewrite the argument as general form. So we go from the English to the more general form where we just replace our terms with these letters. So that's fairly easy. And then comes the actual sort of Venn diagram method. So what you'll see is that because we have sort of three terms, we're going to have a Venn diagram with three circles. And so I'll just try to draw that here for you guys. So you end up having sort of a situation with three circles. Oops, I'm all over the place here. And sorry, that's not a very good picture. But what you will do is you'll sort of draw a picture of the two premises. So whatever the premises are, there'll be some combination of the four categorical claims, and so you'll have to shade some stuff in. For the universals, or put an X somewhere if you have a particular, but you just draw a picture of the two premises. So you don't draw a picture of the conclusion, you just draw a picture of the two premises. And this is, the idea here is that you are assuming that the premises are true, right? So if the premises are true, this is kind of what the world would look like. And in doing these two premises, I just want to mention a couple things. First of all, there's if given a choice between sort of doing a universal and doing a particular, you always do your universals first. You always indicate sort of what areas are empty before you go around putting X's into things, because again, an X can't go in an area that would be empty. And then we should sort of mention that this is a little bit more difficult because we have this sort of third circle. So with two circles, it's a little bit more sort of straightforward, but the third circle always kind of makes things a little bit more confusing. So with some examples, hopefully you'll kind of see how this all sort of plays out. But anyway, so you draw the picture of the two premises, and then, and here's sort of the test here, you check to see if you have a diagram of the conclusion. So you take a look at the conclusion and you kind of think to yourself, well, what would the picture look like if this were true? And if you have that picture, then the argument is valid. And if you don't have that picture, then the argument is invalid. So for example, if your conclusion is a universal, if it were true, then a certain area of the Venn diagram would be shaded in. So if that area is shaded in, then the argument is valid. If the area is not shaded in, it's not valid. If the conclusion were a particular, same kind of deal. If the area has an X in it, like the conclusion says it would, then the argument is valid. If the conclusion does not have an X in it, then the argument is not valid. Okay, so that's the end of this video. The next video, I will sort of go into some examples of how to do this process, and so look for that. So thank you very much.